Hello everyone. This class I am going to explain the continuity of sum of two continuous functions, continuity of not only sum, difference, product, quotient of two continuous functions. And you all can see that I have already settled the coordinate axis in such a manner that along x-axis it gives us the interval of pi only. Okay. So you all have to keep in your mind that in between 0 and pi there is a pi by 2, between pi and 2 pi there is a 3 pi by 2, like that. So when I am going to state continuity of sum, product, difference or quotient of two functions, then those two functions must be continuous. If they are not continuous, if one of them is discontinuous, then sum of two functions cannot be continuous. This can be shown beautifully with this GeoGebra tutorial. This I made for you to explain continuity of sum, product, difference and quotient of two continuous functions. With the help of this GeoGebra I am going to explain it. Just consider the graph of the function fx equal to 2x. You all know this is a line will pass through origin and it has slope equal to 2. Then you take gx equal to cos x. See, both are continuous functions. This line it extends up to infinity. On the number line, this green one, this line y equal to 2x has no point of discontinuity. Similar is the case for the function cosine x. If cos x is taken on the number line, there is no discontinuity of cos x. Now I am going to show you that sum of these two continuous functions always will be continuous. Let's see this function. You can see 2x plus cos x I have settled. Now I make these two up. Previous two you remember. So let us do it with 2x plus cos x. See, the graph has taken. It is being stretched. It is not passing through origin. But this graph is 100%. We are sure that it is continuous at every point on the number line. Okay. So there are two continuous functions, one of them 2x, other one cosine x. Their sum is also continuous function. Let us see their difference. Make this one up. 2x minus cos x if you do, this is also continuous everywhere. Okay. So sum and difference of two continuous functions. This I cannot take all those functions here to show you that sum is continuous, difference is continuous, but I can give you some examples. It's your duty to verify with the same app at home. This hard time, lockdown period, you can keep some time with the play with mathematics with this dynamic software GeoGebra. I have told you earlier also. This is very interesting really. This class 12, class 11, even 9-10 students also have lots of things to prove by using this GeoGebra app. Okay, I'm just giving you introduction here. For continuity, sum of two functions continuous that you have seen. Difference of two continuous functions is a continuous function. I have taken same two because my drawing will be easier. I have taken 2x and cos x. Their product, let's see. See, this is product of 2x into cos x. This function also continuous. Although the nature of the function, that graph of the function is neither like cos x, not like x, not like sin x. It's a new function which is 2x into cos x, product of those two functions. There is no point of discontinuity of this function on the number line. It is everywhere continuous. You all can see. Now let us do the experiment. This sum you have seen, product you have seen. If I multiply by a scalar, like suppose I am plotting it here, I am taking that y equal to say some constant k into cos x. Any constant you take. I have to take a slider here because k is having variable value. If this slider is changing, then once for k equal to 1 I got cos x. This is normal one. Then you take 1.3. Then you take this way, this way, this way. See, changing. What is changing over there? What is the maximum value? 5. What is the minimum value for cos x? You all know 1. So if you go back there, then you will see that This is for 1. It is magnified 5 times when I have taken 5 cos x over there. This slider is fully used, so it is 5 cos x. This is also continuous. So in theory class, we normally say that this you can consider mathematics practical class, one of the practical class. Here we are showing everything with the help of GeoGebra, and it's a dynamic software, so I am using this one like your practical classes. Okay, this practical everyone can perform at home. So some scalar multiplied by cos x. I mean, if fx is continuous, everyone will say that k into fx is also continuous. Okay. Now let us go for quotient of these two functions. I have settled it earlier because it takes long time to type all these and show it to you. I have done it before. Just Rx equal to 2x by cos x. You see. What's the peculiarity of this function? If you go through these points that cos x, where cos x is equal to 0, at those points it will not be continuous. Okay, graph is not continuous. See, at x equal to pi by 2 for your convenience. If I take pi by 2, just take x equal to pi by 2 here. X equal to, I am taking pi divided by 2. See the line. This line is asymptote to the curve. So 2x by cos x, it is not continuous, as cos x is not continuous at x equal to pi by 2. Okay, there is a clear discontinuity of the function 2x by cos x. Let us go for just opposite one. Cos x by, let us go for cos x by x. What do you observe? Is cos x by x continuous? What is your opinion? No, cos x by x is also not continuous, because at x equal to 0 you can see this x equal to 0, I mean y-axis is going to be asymptote. At x equal to 0 the graph of the function is not continuous, so it is not continuous at x equal to 0. Now what about the product of two functions, x sine 1 by x? Will I say this is continuous? Yes, because when it is approaching to 0, it gives us, in theory class we have done that 0 into sine 1 by x, a finite quantity between minus 1 and plus 1, it gives us, will give us 0 only. So x sine 1 by x is continuous when x equal to 0. But if you take only sine 1 by x, this has oscillating value, say at the point x equal to 0. So it cannot have a definite limit over there. Very close to 0, its value is oscillating. A limit cannot have an oscillating value, it can have fixed value only. So the limit doesn't exist here at x equal to 0. Sine 1 by x is not continuous at x equal to 0. Okay. Now let us take the sum of two continuous functions once more. Just sin x and cos x both are continuous. Their sum, see, this is also continuous function. This you can verify yourself. Now it's my duty to show you sum of a continuous and discontinuous function can never be continuous. Just I have told you that sin x is continuous, tan x is not continuous. At x equal to pi by 2, tan x will not be continuous, but sin x is continuous everywhere. See what happens if I take sin x plus cos x, sin x plus tan x. What is your opinion? Is it a continuous function? No, it is not continuous. If you move in between 2 pi and 3 pi, that is 5 pi by 2, at a point in between, the graph of the function is not continuous. There is a clear break at the point 5 pi by 2. There is a clear break at the point 3 pi by 2, at the point pi by 2, at minus pi by 2, at minus. So at all these points where tan x was discontinuous, sin x plus tan x also going to be discontinuous. So this is our learning today. We all will remember that the function that sin x plus tan x is not continuous because tan x is not going to be continuous over there. As one of them is discontinuous, so sin x plus tan x also going to be discontinuous. At the point of discontinuity is same as that of tan x. Tan x was discontinuous at pi by 2, 3 pi by 2, 5 pi by 2. All of you know this. So the function is discontinuous over there. Let us go for this thing. Tan x plus e to the power x. E to the power x graph I showed you so many times. If you want to see it again, I don't have any problem. I can plot these two separately, then I'll show you some of these two is discontinuous. Okay? This is an important thing. This is an important problem to explain with you. So let me plot the graph of e to the power x here. E to the power x. See the graph. This e to the power x graph is not continuous at x is equal to pi by 2 e to the power x. It is not continuous. No, it is continuous everywhere. E to the power x is continuous everywhere. On the number line, if you go on taking the points, it will be continuous over there. But if I take tan x now, I am plotting tan x. Tan x part is discontinuous, obviously. These points, pi by 2, 3 pi by 2, all these points, it is discontinuous. Now when you are going to plot these two, e to the power x plus tan x, I am making these two up. All of you can see e to the power x graph, tan x graph. Let us put this thing out. But I make their sum on, not this one, see this one. Tan x plus e to the power x. This is of course a function which is discontinuous function. Let me make this one off. See, this graph of the function is discontinuous. As tan x was discontinuous, this is going to be discontinuous. Okay. Now I am going to take the two functions in such a manner that they are separately discontinuous. Then what happened to some of their discontinuities? I have to extend that also. Continuity of sum of two continuous functions is established. Continuity of difference of two functions established. Continuity of product of two functions established. That continuity of quotient is done. Continuity of product of this kind of function, that sin of 1 by x not continuous, explained. Now let us take two discontinuous functions. I am taking tan x here, then I am taking cosec x there. Okay. All of you can see this tan x is, if I make this one up, tan x discontinuous at those pi by 2, 3 pi by 2, etc. All of you know it. Cosec x discontinuous when 0, pi, 2 pi, 3 pi all are there. But if I take the sum of these two functions, I am taking tan x plus cosec x. See what is happening there. What is your opinion? Is this a continuous function? No, it is not continuous function. What are the points the function remain discontinuous? The function will remain discontinuous at the point where cosec x was discontinuous, the points where tan x were discontinuous. See, at the point 4 pi plus 5 pi by 2, 9 pi. 9 pi by 2 is this point. At 9 pi by 2 it is discontinuous. If I take 4 pi, not only 4 pi, 3 pi, 2 pi, pi, 0, at all these points it will remain discontinuous. But the continuity of two continuous function will remain continuous everywhere. This is the learning from this article today, that we should keep in our mind that sum of two continuous functions, you know how to find the domain of sum of two functions. Sum of two continuous functions will be continuous in that domain. the difference of two continuous functions will remain continuous in the domain of difference of two functions. Similar is the case for product of two functions, but quotient not always continuous. It will remain discontinuous. If both are continuous function, then it will definitely be continuous. But if the denominator is vanishing because of one of the function, then it has to be discontinuous over there. Okay, denominator if it is equal to 0, like cos x by x I showed you, it is not continuous. And if the function limit is not definite, oscillatory value, then also it is discontinuous. Then sum or difference of two discontinuous function also going to be discontinuous. You all should remember this. So when you do differentiability, it helps us a lot. Not only differentiability, application of derivative, Rolle's theorem, mean value theorem, and other portion of application, it helps. Okay, thank you.